Today's lesson is 1/6 absolute value equation. An absolute value is written like this, and it is the distance from 0 on the number line. Let's look at an example. If I asked you to find the absolute value of x equals 3, if you went and looked at this on a number line, here's 0, 1, 2, 3, 1, 2, negative 3. The distance from 0 to positive and negative 3 is the exact same distance, so this problem has two answers, positive 3 or negative 3. Let's start by solving an absolute value equation. Example 1. The absolute value of 3x plus 2 equals 4. Now we are going to solve this problem differently than the book because when we move on to inequalities we're going to solve it the exact same way, so make sure you're paying attention. So we first make sure that our absolute value is all by itself, which it is in this scenario, and then we are going to add positive and negative and change our absolute value bars to parentheses. Then we are going to start by first distributing the positive sign to our parentheses, which should not change anything. So I just rewrite 3x plus 2 equals 4. Now when I distribute my negative sign for my second equation, it should change both of my signs. So I have negative 3x minus 2 equals 4. If you notice, I did not change the 4 at all. I only changed what was in my absolute value bars. So now we treat these as two separate equations and we are going to solve for x. So I'm going to start by taking away 2. So that gives me 3x equals 2. And then I have to get rid of my 3, so I'm going to divide by 3. So x equals 2/3. Now on my right-hand side, I start by adding 2 since I changed both of my signs. So I have negative 3x equals 6. And then I have to get rid of my negative that's in front of my 3, or in front of my x, I'm sorry. And that gives me x equals negative 2. Now if you take both of those answers and you plug it into your original equation, they should be a true statement. If they're not a true statement, you know you probably made a mistake somewhere. Sometimes your homework or classwork will ask you to graph absolute value equations. This is really basic. You put negative 2, and since it equals it, you just put a dot at negative 2. And then at 2/3, the same thing. Since it just equals it, you put a dot at 2/3. And that would be what your graph looked like if I ever asked you to graph an absolute value equation. Take a second, press pause, and let's see what you get for example 2. So first step, make sure your absolute value bars are all by itself, which it is. So then we put plus or minus, change your bars to parentheses. Now let's go ahead and write our two equations. When you distribute positive, it doesn't change anything. When you distribute your negative, it's going to change both of your signs. Remember, you are not doing anything to the 11. So now let's solve for x. So add 5 to both sides. So 2x equals 16. Get rid of the 2. So x equals 8. Okay, now on the right-hand side, I'm going to subtract 5. So negative 2x equals 6. And then I need to divide by negative 2. So x equals negative 3. Again, if it were to ever ask you to graph this, it's just going to be a dot at negative 3 and a dot at 8. You also can plug in 8 and negative 3 into your original equation to check, and it should be a true statement. So those were pretty basic equations. Now let's move to solving a multi-step equation. Example 3. 2 times the absolute value of x plus 9 plus 3 equals 7. Now, if you notice, on our last example, there was nothing in front or anything behind. So now before we can change it to parentheses and add the plus or minus, we have to get our absolute value bars all by itself. So I'm going to start by removing my plus 3 on both sides. So that gives me 2 times the absolute value of x plus 9 equals 4. Now to get rid of my 2, I divide both sides by 2. So I now have the absolute value of x plus 9 equals 2. Now if you notice, my bars are all by itself, so I can change it to plus or minus, parentheses x plus 9 equals 2. Distribute your positive, shouldn't change your equation, you get x plus 9 equals 2. Distribute your negative, it should swap both of their signs. And now we just get to solve for x. So I'm going to subtract 9 from both sides, and that gives me x equals negative 7. Add 9 to both sides. So negative x equals 11. And then I'm not allowed to leave that negative sign, so I divide both sides by negative 1 or multiply both sides by negative 1. And that gives me x equals negative 11. Again, take both of those answers, plug them into the original equation, and you should get a true statement. You are able to check all of these answers. Press pause and solve example 4. You have 2 times the quantity of 2x plus 8, 2 times the absolute value of 2x plus 8 minus 4 equals 12. Your first step needs to be to make sure that your absolute value is all by itself. So since I have the minus 4 and the 2 in the front, I need to get rid of those first. So I'm going to start by adding 4. So 2 times the absolute value of 2x plus 8 equals 16. And then I need to get rid of my 2. So divide both sides by 2. So I get the absolute value of 2x plus 8 equals 8. Now, since my absolute value bars are all by itself, change it to parentheses, add your plus or minus. Distribute your positive, so that's going to give me 2x plus 8 equals 8. Distribute your negative, negative 2x minus 8 equals 8. Now solve for x. I'm going to subtract 8 from both sides, so 2x equals 0. Then divide by 2, and x equals 0. Add 8 to both sides, so negative 2x equals 16. And then you have to divide by negative 2. So x equals negative 8. Again, take 0 and negative 8, plug it into your original equation, and you should get a true statement. Now we are going to have to check for extraneous solutions. So an extraneous solution is a solution derived from an original equation that is not a solution to the original equation. So now we really have to check our answers. So what's different from example 5 than all of our other examples is, if you notice, I have x's on both sides of my equation. So check over here on the right hand side, are the absolute value bars all by itself? Yes, so we can go ahead and write our plus or minus and change it to our parentheses. So now let's go ahead and write our two equations. Distribute your positive and distribute your negative. And now let's go ahead and solve our two equations separately. So I need to bring my x's to one side, so I'm going to move my smaller one. So that leaves me with negative 2 equals 2x plus 14. Since my x's are now on my right-hand side, I need to move my numbers to the other side. So I'm going to subtract 14. So negative 16 equals 2x, and then divide by 2, and you get x equals negative 8. Now let's do the same thing with our equation on the right-hand side. I move my smaller x first. So that leaves me with 2 equals 7x plus 5x gives me 12x. Since I have my x's on my right-hand side, I need to move my numbers to the other side, so I'm going to subtract 14. So then 2 minus 14 gives me negative 12. And then I got to get rid of my 12 that's in front of my x. So I should get x equals negative 1. Now, take your answers, and you have to really be careful and plug them in. So if I plug in negative 8 into my original equation, I am going to get 42 on my left-hand side, since that was my absolute value. If you notice on the right-hand side, though, I'm going to get negative 42. So since 42 cannot equal negative 42, this is considered an extraneous solution, and I always just write EXT, which means that this is not one of my answers. So now if I plug in negative 1 into my equation, it works for both sides, so the only solution to this equation is x equals negative 1. Press pause and work on example 6, and then check your answer at the end. First step, is my absolute value all by itself? It is. So go ahead and get rid of your absolute value bars, change it to parentheses, and add your plus or minus. Distribute the positive, shouldn't change anything. Distribute your negative, should change both signs. Now solve both of them separately. So I always start by moving my smallest x. Negative 2 equals 3x plus 8. Now move my numbers to the left-hand side. So negative 10 equals 3x. Get rid of my 3. So I get x equals negative 10/3. Now let's move on to our equation on our right-hand side. I always move my smallest x. So 2 equals 5x plus 8. Now let's move our numbers to the left-hand side. So I'm going to start by subtracting 8. So that gives me negative 6 equals 5x. Divide both sides by 5. And so I get that x equals negative 6/5. Again, since I had x's on both sides of my equation, I really have to check for extraneous solutions. So if you plug in negative 10/3 into the original equation, you should not get a true statement, which makes this extraneous. So now let's check our other one. Don't just assume that they both or the other one works. It could be no solution. They could both not work. So plug in negative 6/5 into your original equation to see if you get a true statement. And you do. So your only solution should be negative 6/5 for example number 6.